Hello everybody, welcome to this fourth video of the agroecology lecture. Today we will talk about soil protection. We will not go back to the basic of soil science and chemistry. You can read the document the chapter 2 of the document if you have things you forgot and you didn't understand about the basic, but we'll just talk about more generally soil protection, what we can do to protect our soils. So there will be just a small refresh about soil fertility, but not a lot because I assume you are quite confident with it. Then we will talk a little bit about the characteristics of soils in sub-Saharan Africa, and then mostly about the threats to the soil and what we can do to protect them. So firstly about soil fertility, a quick reminder on soil organic matter. So it's the part of the soil which is of living origin composed mainly of carbon, but also oxygen, hydrogen and nitrogen. It is essential for soil fertility and plant nutrition because it has a very large specific area that can hold a lot of nutrients, and it can provide these nutrients to the roots of the plant. It has a high CEC, so an availability of basic cations that you often otherwise do not have in a all tropical soil, and it creates this so-called clay humus complex, which is kind of cement for the soil. So it really has a structural estrogen role to protect the soil and prevent it from erosion and destruction. It is a source of energy for a lot of soil-borne organisms, bacteria, fungi, animals, insects. And a few words about the dynamics. So you have your soil organic matter in the soil. What are the inputs? What are the outputs? So you get organic matter from animal defecation, so mostly in agricultural lands because of the adding of manure, which is animal feces, and with the decomposition of plant residues, so roots, stems, leaves, and fruit. So that is the input you get in the soil, and you lose it on the other way by erosion. So, for example, water runoff or wind can remove some part of the soil, some part of the organic matter. You have leaching of organic matter that can be so the water can take the organic matter with it and bring it in deeper layers where you cannot get it back. You have mining of mostly of the nutrients that are in the organic matter, and through this decomposition you lose the organic matter, and you have mineralization of organic matter, so the decomposition of organic matter back to minerals so that the plants can take it. So this is the four outputs of organic matter that you have in the system. The mineralization of organic matter is really essential, especially in the tropics. And so it is the decomposition of the organic matter by soil organisms that produce CO2 and molecule that can be taken up by the plants, and nitrates, phosphate, ammonium, etc. This needs air to happen, so you need a contact with air, and it goes quicker in a hot and humid climate. This is why in the tropics, where you have a hot and humid climate, you have a potential high mineralization of organic matter, so you can lose your organic matter really quickly if you don't prevent it, and if you then compensate the loss by adding new organic matter. And there are also artificial factors that can influence the mineralization of organic matter, and this is the so-called priming effect. So if you add a fertilizer of mineral composition, nitrates, phosphate, and so you will add some nutrients which will support the growth of microorganisms that decompose organic matter, so you will quicken decomposition of organic matter, and that way you can lose your organic matter quickly if you don't compensate it. This is why it is advised to always add organic matter to the soil, so to combine mineral fertilization at the minimum with organic amendments. And then a few words about the CN ratio. So it is the concentration of carbon in the soil divided by the nitrogen concentration. It gives a good insight on the soil composition. If you have a high CN, you have a lot of carbon, a few, not much nitrogen. So for example, a CN above 20. And this means there is not enough nitrogen for the plant, so the plant will not grow well because of lack of nitrogen. And if you have the opposite, high nitrogen, low carbon, so a CN under 5, you will have what we discussed before, an accelerated mineralization, and thus a loss of soil organic matter, and in the long term, a loss of fertility. So ideally, you have a CN between 15 and 20. The CN is also useful to characterize soil amendment or fertilizer, so that you can know what will be the impact of the amendment of the fertilizer you bring. If you bring an amendment with a high CN, you will kind of starve the plant, but you will on the long term bring fertility to the soil. But if you bring fertilizer with a low CN or even no carbon at all, then you will cause this priming effect and accelerate the mineralization. So that was just some refreshing on a few of the soil fertility aspects. Now we will talk about soils in sub-Saharan Africa. The first example that we find a lot in sub-Saharan Africa is the ferralitic soil, which we find mostly in savanna and forest areas. There, the soil has been influenced for millennia by a hot and humid climate and by intensive rainfall. And to this, there a chemical and physical alteration of the parent rock and primary minerals occurred. So basically, over thousands of years, you had a constant leaching of the mineral produced by this process, and so you lost all your base cation and alkaline minerals, so you have a loss of buffering capacity and a really acidic soil. To this process, you also had a leaching of the nutrients over time, so you have a soil that do not have much more nutrients left. This led also to, by leaching everything that was produced, you had an accumulation of the undegradable mineral that stayed behind, so quartz, iron oxides, and unalterable clays. So these are minerals that have a low specific area, a low CEC, and thus these minerals are not able to retain water and nutrients. So you have a soil that has a really low capacity to retain nutrients and water. In addition to that, these minerals have a high capacity to fix phosphorus, and thus you have a low availability of phosphorus in this soil. So these typical soils are the feral soils. So these typical orange-red soils. Then you have the leach soil, so the acrisol or the lixisol. You can find them mostly in the areas where you have an alteration of dry and wet wet seasons. And to this alternation of wet and dry, you had the leaching of clays to deeper horizon. So it means it's a soil with a low clay content on the surface of the soil, and thus you have a low water and nutrient retention capacity. We can also find the splinter soil, so the petrified ferralitic soil. In case of really strong alternation of dry and wet periods, you can have this creation of this splintite or laterite, so these hardened iron oxides. So then it's really an extreme impoverished feral soil with low nutrient retention, high P fixation, and to this creation of these iron stones, really difficult to manage also mechanically. You have a more fertile soil in the tropics than the one I just shown. You have the combi soil, so the brown earth that we can also find in Europe, which has a high CC, a good availability of nutrients, and not much P fixation. And then you have the soil, which I think can be found a lot around Jima, with a medium CC, a good nutrient availability, and not too high phosphorus fixation. So to summarize, the mineral origin of tropical soil usually have poor water and nutrient retention, a low cation exchange capacity, so a low availability of basic cations, a fixation of phosphorus, and low and content and low availability of nutrients, and acidic, and they are acidic. So to conclude, we can say that organic matter is of crucial importance because it can provide everything that the mineral horizons of these soils cannot. So that means the organic matter can provide water and nutrient retention, can provide uh, cation exchange capacity, can provide nutrients, can provide a buffer against acidity, and can prevent pay fixation in the upper horizons. So now we will look at the possible threats for these soils. So as we just saw, the main danger is the loss of organic matter because these soils are really are mostly infertile if you don't have organic matter. And this is a difficult task, mainly linked to the hot and humid climate where you have a strong decomposition and to the intensive rainfall in the rainy season that can cause an intensive erosion and leaching. So basically, if you don't have a primary forest that can compensate, that have a equilibrated system, you will lose organic matter in the tropics from your soil. So you really need a constant input to compensate these losses. Uh, we can look at this map again that I shown in the introduction of the major risk to the soil. So we can see that in Africa, everywhere in Africa, the first risk is erosion, uh, followed by also organic carbon change. So in that case, the risk of mineralization of organic matter, and finally we have a nutrient imbalance. So the risk of nutrient mining, farmers that plant crops and do not fertilize them enough, and that we get the nutrients out of the soil, and finally acidification of the soils. So these are the main threats that are identified for sub-Saharan African soil. So the first of them, the mineralization of organic matter. So we already talked a bit about it. So it happens quickly in a hot and humid climate, so which is almost everywhere in sub-Saharan Africa. It's a problem if you don't fertilize with organic amendment because by doing so you do not compensate the losses. It's strengthened if you have a soil exposed to the air, for example a bare soil, because you will have more contact with oxygen, so you will have a quicker decomposition. It's also higher if you have a soil turnover, either by ploughing or by harvesting tuber. That by doing so you also expose and get air into the soil, and which promotes the decomposition. Mineral fertilization can strengthen the loss of organic matter by mineralization because you will have this so-called priming effect that I mentioned before. Burning, of course, burning is a mineralization of organic matter. So if you have a slash and burn system, you can lose a lot of organic matter by mineralization. No or insufficient fertilization, which is also related to nutrient mining. So these are all the reasons that can cause the mineralization of organic matter in the tropics. Then you have erosion, which is the water and the wind that is taken away your soil, inclusive its organic matter, which we saw in the introduction, can become really dramatic if it's not controlled in some areas. So erosion is mostly intensive. You have intensive rainfall. If you have a soil not covered, if you have a soil that was turned over or its structure destroyed, for example, through plowing or through harvesting of tubers again. And of course, if you don't take any measure to limit erosion, especially if you have a slope land, you will get soil loss through erosion. If you don't have enough organic matter, because as we said before, this humus clay complex acts as a cement and prevents erosion. And then burning usually leave a complete bare soil without any structure, so this can be then easily washed away by rainfall. The next danger is acidification. So first of all, we have to say that in the tropic, acidic soils are normal, they are natural. They are so because they are really old and they found themselves in a hot and humid climate, so they lost their buffering capacity. And plants also, mostly legume, participate in this acidification, so you have a part of the acidification which is natural. But legumes secrete acid root exudate to facilitate nutrient intake, and by doing so they can also acidify the soil. So if you have a legume monoculture like only soy the whole time, you can get an acidification through this. Fertilization can also cause acidification because you have a lot of fertilizers that are acidic, for example, ammonium for nitrogen fertilization, and almost all of the phosphate fertilizer are acidic. So, for example, the triple phosphate fertilizer. The lack of use of countermeasure, for example, if you use lime or tryptophan dropping to raise the pH and compensate the acidification, and the loss of organic matter because organic matter acts as a buffer and can, by doing so, stabilize the pH on a more neutral data. And of course, burning causes also acidification to the loss of organic matter, for instance, and also to the process of burning itself cause production of acids in the soil. So with just a few more specific words about burning. So if you have an intense burning of a forest or a savanna, you will get a high mineralization of soil organic matter, and it was evaluated that about 3/4 of the nitrogen that you have in your system, inclusive the one in the soil and in the plants, will be lost to volatilization, will be lost to the atmosphere, and 50% of the phosphorus. So this is during the fire, you will almost lose all your nutrients. Even the one who will stay will be available, and this is why you will get a good yield just after the fire, but in the long run you will have lost almost everything. And after the fire, you have a high erosion because of bare and exposed soil. You also have high leaching because of this, and you also have high mineralization because you have contact with the air in the absence of cover. So these were the main threats for the soils in sub-Saharan Africa that we talked about. So now we will see what can be done to protect them and prevent these threats. So basically you have we can summarize in 5 objectives to protect the soil that will protect against one or more of the different threats. So first, to protect the soil and its organic matter from rain. That way you will prevent leaching and you will prevent erosion. Protect the soil and its organic matter from the air. That way you will diminish decomposition of organic matter, and you will also, by doing so, also limit the loss of nitrogen through volatilization. 3, add organic matter to compensate for losses, because it doesn't matter what you do, you will anyway lose organic matter, except if you just let the forest grow. And if you lose organic matter, you need to compensate these losses, so you need to add organic matter. It can be mulch, it can be manure, biochar, anything, but it need to be added. You need to add nutrients first. You need to add nutrients to compensate for the loss on the exports of the nutrients in order not to impoverish your soil in a specific nutrient like nitrogen or phosphorus. And 5, you need to increase or stabilize the pH to avoid acidification, which can, after this, cause a lot of fertility problem. So these are different measures that you so these are 5 objectives that protect the soil from one or more of the different threats. And then there are a lot of measures that we can take that will meet one or more of these 5 objectives. So first, we can plant crop association. This will optimize space, and by doing so, you will have a better soil coverage, and thus you will protect the soil from erosion and from contact with the air. You will also be able to fill the gap between rows of a slow starting crop to also protect the soil. And you can associate trees with annuals, and that way you will diminish the speed of raindrops and also diminish erosion. And finally, in crop association, you can associate destructive crop with protective crop for the soil, and that way limit the negative impacts of the crops that are not good for the soil. Crop rotation, by doing so, if you make a good rotation, you will be able to cover the soil at all times, which will protect it from the rain and from the air. You can alternate demanding crop with less demanding crop. So if you get a lot of nutrients out with one crop, or if you have a crop that provoke a loss of organic matter, you can the next year bring a crop that will be less demanding in nutrients, or that will be less harmful for the organic matter of the soil. So yeah, you can alternate destructive crops with regenerative crops. For instance, after cassava, which is really destructive for the soil because you expose it to the rain, to the air, then you could plant a green manure that can bring a lot of organic matter to your soil. And you can also alternate crops that need different nutrients. And anyway, you should never leave the soil bare if you plan a good rotation. And you should at some point plant a green manure to recover and bring organic matter to your soil. A few recommendations for an efficient rotation. So we already discussed a bit rotation in the pest management chapter, but you should cultivate species in the decreasing order of requirement in nutrients and sensitivity to disease. You should always cover the soil to protect it against erosion, leaching, and loss of organic matter. If you have no crop in mind, you can sow something, a green manure, to cover the soil, especially in the dry season. And you should every 3 years plant a green manure. We already gave some information for rotation, mostly regarding the pest management issue. So today we'll just a bit look at it regarding the soil protection and fertility issues. So a few information about the different families that you can put in the rotation to plan it correctly according to this idea to protect the soil and to maintain its fertility. So the family of grasses of cereals are demanding in nitrogen and phosphorus. They are interesting because they can recycle nutrients from deeper layers, and they, especially the C4 cereals, can produce huge amount of biomass, including roots, so that way they can really enrich the soil with organic matter. So especially with green manure grasses, you can really bring a lot of organic matter to your soil. Legumes are not really demanding except in phosphorus. They are able to fix nitrogen from the atmosphere. They are able to mobilize phosphorus from the soil. That can be interesting to get phosphorus for other crops, but it can also cause acidification, as we said before. But they can be used to enrich the soil in nitrogen. For this, they are a really interesting green manure. Underground crops are really to be considered for rotation as really something dangerous because they usually involve soil turnover and they often are slow-growing crops, so they implies a low soil cover for a long time. So you often have a high risk of erosion, leaching, and loss of organic matter. So they are basically destructive crops except sweet potato, which can grow quite quickly and cover the soil really nicely. So you can still cultivate them, but you should alternate them in the rotation with regenerative crops such as legumes or green manures. And I wouldn't advise to cultivate them more than 1 year out of 4 because of the risk for the soil that they imply. If you add some soil protection measure like mulching, associated crops, agroforestry, you can cultivate them more frequently. And of course, you should respect the breaks for pest issues of the families they belong to. So again, we're getting back to the soil protection measure. After erosion, we have the mulching that can be used to cover the soil between crop rows. It can also be used to cover the soil in the dry season. So it's basically important to protect the soil from erosion, leaching, and soil mineralization, so organic matter mineralization. You can plant green manure. So a green manure we will get more precisely in the future, but it's a crop that is grown in the with the goal to protect or to regenerate the soil and not to produce something. So it's usually a plant that produces a large amount of biomass so that you can bring a lot of organic matter into your system and eventually into your soil. It's a crop that can mobilize soil nutrients to get them in available uh, uh, form and to be able to give them to your crops. It can be used to add nitrogen to the system if it's a legume. And then if you, to the green manure, you produce a lot of organic matter that can contain a lot of mobilized nutrients or fixed nitrogen, and you can then bring it to the soil either by as a mulch, by composting it, or by feeding it to the animals and then bringing the manure to the soil. So by all these ways, you will get organic matter and nutrients to your soil. Um, the next protection measure is an adapted fertilization. You should fertilize so that it matches the crop needs, not less to avoid nutrient mining. And also, you should not fertilize only minerally because by doing so, you will not compensate the loss of organic matter and you can cause a priming effect and accelerate the loss of organic matter. You can do a conservative soil management, so that means working the soil superficially and locally in the place where you want to plant. By this way, you will not turn the soil over, so you will not expose it to the air, thus prevent mineralization of organic matter, and also you will keep its structure, and by doing so, limiting erosion. So you have here an example of a so if you get to the extreme, you can practice a no-till system where you don't plow at all. By doing so, you will really limit the loss of organic matter because you will not expose your soil to the air at all. You will also heavily prevent erosion. but it can be difficult to manage because of weeds, because of ability to seed in the to sow in the end plowed soil, but you will really keep a good structure like you can see on this scheme, and by doing so you will really protect the soil. So ideally we should do this when we think of the soil, but for pest issue, for weed issue, for practical issue, it's difficult to really practice it. Then you can plant hedge. They will limit runoff and erosion. You can plant them around your plots, around your farm, and to stop the water from running across your farm. You can use stone barriers, which is digging a ditch and putting wax in it. So this is the same idea as hedge. You will stop the water from running off, and you will keep the water in your plots and prevent erosion. Uh, to control acidity, there's a few things you can do. If you fertilize minerally, you can use nitrate fertilizer or urea, which are not acidic fertilizer, instead of ammonium. So you should avoid the use of ammonium if you have an a pH problem in your soil. You should limit the use of synthetic phosphorus fertilizer. They are all acids. So you should prefer organic fertilizer, which can act as a buffer, and especially chicken manure. So if you add chicken manure, you can really increase your pH and fight your acidity, because chicken manure is really a basic, contains a lot of basic cations, has really a high pH, and can be really effective at controlling acidity. You should protect your organic matter because it acts as buffer. You can apply lime to get pH up again, and you should not overload your rotation with legumes. So that was it for the lecture about soil protection, the different measures that we can take to protect it. And the next chapter we'll talk about water retention techniques, which are really related to this erosion and soil protection issue, because usually the practice that you do to protect your soil are also effective at retaining your water in your system and the other way. So thanks a lot and have a good evening.